Hi class, today we're going to be talking about the contents of Chapter 1 in the Cosby and Bates text, Scientific Understanding and Behavior. I want to give you a few moments to just read this disclaimer. Go ahead and feel free to hit the pause button. The take-home message here is please don't use these slides for anything outside of this course. Okay, so let's go over what some of the learning objectives are for this particular chapter. First, we want to talk a little bit about why it is important to understand research methods. Second, describing the scientific approach to understanding behavior and contrast it with pseudoscientific research. One of the things that you all will hopefully figure out as you progress through this class is that much of the information you might read on the internet or through popular media is actually not scientific research. Despite it being dubbed scientific research, it's actually pseudoscientific. Next, we hope to define and give some examples of the 4 goals of scientific research, which is to describe information, make predictions, make some determinations about various causes, and explain behavior if we can. We hope to also discuss the 3 elements for inferring causation: temporal order, covariation or cause and effect, and elimination of alternative explanation. Don't feel too overwhelmed. I know it's a lot of terminology, but we will get through it. Finally, we'll try to define, describe, compare, and contrast the differences and similarities between basic and applied research, because both are important and complementary aspects of research. Many students probably come into a research methods course and feel a little bit anxious or a little bit sick about doing research because people tend to have a little bit of a antipathy towards the term research. They might feel like it's boring or overwhelming or just too hard to understand. Believe me, I felt the same way when I took this course many years ago. However, after I took this course and many others like it, I began to realize the importance of understanding the contents of this course, even at an elementary level. And so I have a better appreciation for why becoming an informed consumer of research why it matters. It helps to improve critical thinking skills. It helps us to evaluate the credibility of various sources of information. And it helps us to be able to digest and weigh the relative strength of information more effectively. It's also worth noting that there are many jobs and occupations out there where this is their job, to actually do research and be able to weigh and evaluate different aspects of competing research as either part of their job or to help their field evolve. Also, many public policy decisions are made by politicians and other administrators based on scientific research. Obviously, if we had bad research, that would lead to some pretty bad public policy decisions. So it's important to understand the research, understand its limitations, understand the findings so that we actually develop good public policy decisions. So I think most people know the old phrase, trust your gut. And intuition certainly has its place in human functioning, but what many people do that's actually a mistake is to rely more strongly on their intuition or their own personal experiences, something that we call anecdotal evidence, to draw general conclusions about the world around them. But unfortunately, using your intuition actually leads to more mistakes than actually following the research. One of the things that I hope to be able to impress upon this class is that people have a wealth of different cognitive and motivational biases that affect our perceptions and can lead to some erroneous conclusions and some actually really terrible outcomes for people. For example, the cognitive bias called illusory correlation occurs when we focus on 2 events that stand out and occur together. One of the best examples I try to impress upon people is that there is a correlation between increased number of ice cream cone sales and homicides. This is a real correlation, but it's an illusory correlation. It doesn't mean that murderers like ice cream, or that if we eat more ice cream we become murderers. There's actually a different reason why these things are correlated, and it actually has to do with summertime. Summertime has more homicides, and it has also increased ice cream sales. Similar to how we can make some mistakes based on our cognitive biases, as well as being overly reliant on our intuition, we can also be easily misled by sources that we think are authoritative. Unfortunately, not every source that we get information from can be fully authoritative. Unfortunately, people tend to be more easily persuaded to believe certain ideas when the speaker happens to be prestigious, trustworthy, and respectable. Also, people tend to become overly reliant on information they receive from social media, news media, internet sources, books, government officials, celebrities, religious figures, and even professors. Yes, you heard me correctly, even professors can be wrong. And simply because they're in an authority position doesn't necessarily mean that they are correct. Rather than relying on our gut level intuition or messages from authority figures, the scientific approach rejects the notion that one can just simply accept information based on faith by any sort of authority. When reading scientific research, it's important to be at least somewhat skeptical. The things that we want to do when we're reading research is try to identify flaws in how ideas were generated in the first place. And even good ideas deserve to be thoroughly tested. And this is where the idea of empiricism comes from. Empiricism requires our base knowledge to come from observational data, and we collect this data to form the basis of these conclusions that we hold so much stock in. But this isn't just based on any old data that we can collect. It has to be data that we collect based on best practices in the data collection methods. So if we want to think like a scientist, what should we consider? The data has to play a central role in the information gathered that leads to our conclusions. It can't just be our gut level intuition or information from authority figures. Also, we have to know that scientists are not alone. Scientists and other professionals are also tasked with the responsibility of challenging each other and keeping each other in check, so therefore science can also be adversarial. This means scientists seek to support and sometimes even disprove their own and others' research. This is typically done through a process called the peer review process. Put simply, the peer review process is a process wherein scientists present their research to other scientists in the same field of expertise and give everyone else a chance to criticize it and effectively challenge it. The more scrutinized a particular piece of research is, the more robust the findings will be. Okay, class, so don't get me wrong. It's not a bad thing to have opinions or intuition. This is how we get to the point of developing ideas for research in the first place. But until they're effectively tested, opinions are just opinions. But again, we should be skeptical of research reports in the media, assertions made by scientists, and pseudoscientific research. One of the best questions that I have heard another scientist ask is, how do you know what you know? Scientists should be able to show their work, and their work product should stand up to that scrutiny. Hopefully, by the time this class is over, you'll be able to effectively weed out some of the non-scientific claims that are being sold as scientific. This will help you wrap your mind around the term pseudoscience. So here are a few tips for beginners on how to develop skills in consuming research. First, ask yourself what was being measured. and perhaps even more importantly, how it was measured. I remember when I was a graduate student and working in a hospital, I was on a team that reviewed research articles. In one of the articles that was presented, there was a claim that a particular medication was very effective at reducing depression. However, when we took a look at what they were using to measure depression outcomes, it was a pretty flimsy depression questionnaire. So, when we know that researchers might be using less than optimal methods for reaching a conclusion, we can also know that a particular study's findings might be misinterpreted or just flat out inaccurate. A second and very important consideration is how researchers make claims about how one thing caused another. We can know based on their research design and how their data was measured and collected whether a researcher can actually make that claim. Sometimes, unfortunately, researchers get ahead of themselves and make overly ambitious statements or claims about their findings. A third question to consider has to do with generalizability. For example, if research is completed with one population, do those findings necessarily translate to a similar outcome with another population? So, a real-world example might be if we have a psychological test that helps us make determinations about the abilities of people with dementia, could we reasonably use the same test and hope that it applies to individuals with brain injuries or strokes? Do we really think it's appropriate to make that kind of a leap? A fourth question has to do with replicating results. Ideally, if a researcher completes a study and has solid findings, these findings should be achieved by any other researcher using the same methods. If they can't replicate the findings, then this suggests that maybe the theory was weak to begin with, that maybe there was something wrong with the method or the people in the study, or maybe some other factor that led to a different outcome. Here are some of the goals of behavioral research. Psychologists in particular do their best to try and describe behavior in useful and sensible ways. One of the things that psychologists also try to do is make accurate predictions about behavior. This is incredibly difficult to do, but there are some factors in the research that help us make pretty good guesses about how people might respond to a certain situation or stimulus. One of the famous questions posed by psychologists, or I should say to psychologists like me, is, why did that person do that? Which is another way of asking about causes of certain behaviors. And finally, we hope that solid research can help us understand behavior and develop logical and rational explanations for that behavior. Some of the historical studies on animal research and classical conditioning that you learned about in Psychology 101 should come to mind here. There are lots of ways to describe behavior. There are really obvious ways where we can simply record the number of times a person does something, like the number of times my kids leave dirty dishes in the sink, or less observable aspects of behavior like the perception my kids might have of being scolded. Also, researchers are often interested in describing the ways in which events might be related. One famous question has to do with whether people who are more physically attractive get differential treatment compared to people who might be less physically attractive. So, extending that idea, one place where we would hope this would not be a factor would be in criminal trials. But it would be an interesting topic to research and find out what the results would be, don't you think? So here is an interesting graphic from the text that describes typical computer-related behaviors of kids ages 8 through 18. We can see that there is a good amount of variability, but isn't it interesting that much of these behaviors are connected to entertainment and connecting with other people? Perhaps an even more interesting question might be, what happens when we break this down into smaller age groups? What would 8 to 10-year-olds look like on this pie chart compared to 17 and 18-year-olds? It would certainly be interesting to see if there were any meaningful differences. Why is predicting behavior important? Well, there are lots of reasons why a psychologist might be interested in this. Using the example from before, if we know that more attractive defendants tend to get more lenient sentences in criminal trials, when we actually see an attractive person being prosecuted, we might be able to predict a more lenient outcome. It seems only logical, right? But let's be more serious for a moment. One example I am familiar with is whether air traffic controllers can pay reasonably good attention to a large number of data points all at the same time. And at what point are there too many data points before an air traffic controller starts making mistakes? This would certainly be important information to know, right? And obviously, when we design an atmosphere and working conditions for air traffic controllers, we'd want to ensure that they only focus on a small number of things at a time and have minimal distractions. This is why the ability to make accurate predictions can be super helpful in making better decisions. Here is another graphic from the text worth talking about with respect to making determinations about cause and effect. On the top in the blue circles, one statement that might be made is that we can look at a person's behavior of playing violent video games and then subsequently look at the aggressive behaviors that follow. So here we're looking at sort of a timeline in which one behavior occurs before another, and then inferring that one actually causes the other. A second way to study the same phenomena and try to make a causal attribution is that we can examine the relationship between playing violent video games and aggression, and then note that when these same people don't play violent video games and no aggression is observed, such as is indicated in the orange circles. Again, we have to infer here that the violent video games caused a behavior that is otherwise not observed when violent video games are not being played. As always, alternative explanations may exist. For example, in the greenish circles, we see that lack of parental supervision might also be a cause for aggression just as much as playing violent video games is. Behavioral scientists seek not just to identify a relationship between variables, objects, or concepts, but also to explain that relationship. How does it happen? What is the mechanism that is operating here? As you can see, asking about the mechanism of how something works is a question that isn't really answered even when knowing a relationship exists. Sometimes behavioral scientists make a hypothesis to explain a certain behavior, and that hypothesis turns out to be incorrect. And when that happens, we revise our thinking, we develop or modify our theories, and then we try again. Here is an opportunity for my nerdiness to come out. I love the discussion about basic research and applied research. Basic research is kind of an incorrect title or misnomer because it's rarely, if ever, basic. What basic research is this more abstract, conceptual research. It tends to be research that focuses on specific phenomena, and they study this phenomena in highly controlled situations like laboratory settings. And this research is often meant to support a particular theory. For example, ASU conducts research on the types of decisions a jury might make depending on certain defendant characteristics or events that happen in a courtroom. However, this research is conducted in an artificial setting where there are no bad outcomes and that there are tight controls to prevent or limit alternative explanations. So the strength here is that the cleanness of the lab studies has just what we can't get in the real world. Also, we don't have to risk any potentially bad outcomes. Now, contrast that with applied research. Even though the real world can be much more messy and have all sorts of alternative explanations, it is useful to know why certain things happen. For example, in the real world, we might be interested in how often judges are affected by their own biases in courtroom decisions. This would certainly be some real-world research worth doing. A second level to applied research is program development, which can examine the sorts of problems that I'm exemplifying here and even help determine what types of meaningful changes can be implemented that create positive change. Okay, class, one last slide here. Both basic and applied research are necessary. Actually, I would say that they are complementary, meaning that one often leads to the other, and around we go. One really unfair criticism of basic research is that it's not real or doesn't apply to the real world. Well, that's not necessarily true. There are some really important findings that occur in basic research that bring our attention to the phenomena that we later find ways to study in the real world, but we would not have ever even known existed without the basic research in the first place. So, both basic and applied research are both needed to advance science and benefit society.